The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. The dwarf planet Pluto is the furthest object in our solar system. Hundreds of thousands of minor icy planets and asteroids populate this region of space within the Kuiper Belt. Once thought to be the ninth planet in our solar system, Pluto was named after Pluto, the Roman god of the underworld. Pluto, however, lost this standing in 2006. According to current scientific theories, the solar system contains innumerable asteroids, a small number of dwarf planets, and just 8 planets. Our knowledge of the universe has expanded greatly over the past several centuries, and we now have a good idea of how planets operate, what they're made of, and whether or not they may house humanity in the far future. But perhaps there is still a great deal to discover about the stars in our own galaxy. What mysteries has the James Webb Space Telescope finally solved about Pluto? Does it harbor life, either known or unknown, and does it have an interior ocean? Join us as we explore the incredible mystery of what the James Webb Space Telescope discovered on Pluto that was hidden all along. The ninth planet, Pluto, was much admired for 76 years. No one noticed that it had the smallest moon in the solar system. The fact that its orbit was skewed and oval didn't bother anyone. Pluto was a bit of an oddball, but it was our oddball. Kids can relate to it because it's miniature, and many adults can identify with its plight as an outcast. The populace felt compelled to defend Pluto. That there was public outrage when Pluto was reclassified as a minor planet 15 years ago is perhaps not surprising. The IO revised their definition of a planet, and Pluto was left off the list. According to the revised criteria, a planet must possess 3 characteristics. First, it has to orbit the Sun. Second, it needs to be massive enough that its own gravity can shape it into a sphere or something near one. Third, it must have removed any debris from its orbit. Pluto failed the third and final evaluation, so we have a dwarf planet. The term planet has been used in a much broader sense for millennia. In the 1600s, when Galileo trained his telescope on Jupiter, everyone thought any big orbiting object in the sky was a planet, even moons counted. When astronomers first discovered the rocky rocks we now refer to as asteroids in the 1800s, they also referred to them as planets. From the start, Pluto was considered to be a planet. It was initially seen in January 1930 by amateur astronomer Clyde Tombaugh using photographs obtained through a telescope. Tombaugh, a current employee at the Lowell Observatory in Flagstaff, Arizona, immediately reported his finding to the observatory's head, "I have found your planet X." He boasted. Tombaugh was alluding to a hypothetical 9th planet that would orbit the Sun beyond Neptune. However, things took a strange turn when it was discovered that Pluto wasn't alone in the universe. Beyond Pluto's orbit in 1992, an object only a tenth as wide was found. Since then, almost 2,000 frozen bodies have been discovered in the Kuiper Belt, the coldest region of the solar system's outskirts. There could be a great deal more to come. Questions were raised when it was discovered that Pluto had so many neighbors. What did these unfamiliar planets have in common with Earth? Why did they stand out? Suddenly, astronomers were confused about what constituted a planet. Professor Mike Brown, a planetary scientist at Caltech in Pasadena, discovered the first Kuiper Belt object visible at the time that seemed to be larger than Pluto in 2005. In commemoration of the television show Xena Warrior Princess, its name was changed to Xena. This icy remnant was created when the Sun and planets were very young. Brown suggested that Xena should be the 10th planet if Pluto was the 9th. However, if Xena didn't merit the status of a planet, then neither does Pluto. In 2006, disagreements over where to place Pluto and Xena reached a boiling point. The action culminated at a conference of the International Astronomical Union in Prague. After extensive discussion, a revised definition of a planet was offered for a vote on the last day of the August meeting. Dwarf planet status was awarded to Pluto and Xena. Eris, the Greek goddess of strife, is now known as Xena, given its importance in shaking up our understanding of the solar system. The name is apt. Since Brown's work contributed to dethroning Pluto as a planet, he has earned the Twitter handle at Pluto Killer. Posters and textbooks were reproduced and updated immediately. However, many planetary scientists have never updated their methods, and this is especially true of those who focus on Pluto. That could be sarcasm or malice on their part, but others argue in 2 papers that there are also valid reasons to reject the IO's definition of a planet. The scholars read numerous books, articles, and letters to compile this information. Some of the papers were centuries old. They illustrate the multiple incarnations through which the term planet has been used by scientists and the general public, and the reasons were not always obvious. Ceres is an example. Between Mars and Jupiter in the asteroid belt is where you'll find this thing. After its discovery in 1801, Ceres was given planet status alongside Pluto. As more objects were discovered in the asteroid belt, Ceres was claimed to have lost its planet status. Scientists had determined that Ceres had hundreds of neighbors by the end of the 1800s. According to the legend, Ceres lost its planetary status because it was no longer noticeable. That's how Ceres and Pluto were similarly afflicted, right? A planet-like globe with higher global contrast than any other planet in the solar system, including Earth. In July 2015, New Horizons famously observed a heart-shaped feature just north of the near-side's equator, confirming that Pluto is indeed a dynamic world. Sputnik Planitia, a frozen basin roiling and flowing with enormous glaciers, is located within Pluto's left ventricle and is now known to have a profound impact on the planet's dynamics. Pulses of sublimating ice rise into the air as the sun warms the frozen plain, only to fall again when night falls. It's possible that the beating of the heart tipped Pluto over. Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, and his colleagues noticed something odd about Sputnik Planitia not long after the first photographs of Pluto's near side were sent to Earth. It is situated almost perfectly opposite Pluto's largest moon, Charon. The chance of an accident occurring is 5% at most. Instead, simulations show that a subterranean sea began to rise into the rift just as the basin was forming. Nitrogen gas from Pluto's atmosphere condensed and froze in the icy crater. Pluto's current alignment is the result of a huge burden caused by the accumulation of additional water and ice. The concept of an ocean beneath the surface is not new, but the far-side photos have provided significant support for this theory. Some of the most convincing evidence comes from chaotic terrain, a confusing patchwork of hills, fissures, and plains located on Pluto's opposite side from Sputnik Planitia. Scientists believe that an asteroid or comet impact caused seismic waves to rip through and around Mars, Mercury, and Europa, one of Jupiter's moons. When these earthquakes finally collided on the opposite horizon, they tore the surface in ways similar to what we see on Pluto's icy moon, Charon. Planetary scientist Oliver White, from the SETI Institute in Mountain View, California, who did not participate in the study but did create a geologic map of the far side, contends that the feature does seem to mimic ones observed elsewhere in the solar system, but that the resolution in the image is low. A majority of other scientists share this opinion. Perhaps we won't know unless we make a return trip. The discovery of numerous fractures on Pluto's far side, among other geological peculiarities, lends credence to the idea of a subsurface ocean and may even provide insight into the planet's formation. For a long time, scientists have speculated that Pluto's ocean had a cold start, meaning that it was frozen at the time the dwarf planet was formed. Eventually, the radioactive decay in its rocky core would have produced enough heat to dissolve it. The ice would have shrunk as it melted, causing ripples on the surface, adds Nimmo, much like the wrinkling of an apple after being stored in the fridge. This expansion of the ice as it refroze would have led to surface cracking. If this is the case, then Pluto's surface should appear wrinkled and cracked in photographs taken recently. However, New Horizons only captured images of fissures, indicating that the dwarf planet's ocean was once liquid but has now frozen partially. For instance, photos of Pluto's far side show a huge crack that runs the length of the planet's near side. It has progressed to the point that it wraps around the entire dwarf planet, from the North Pole to the South Pole on the opposite side. Like the East African Rift System, which divides that continent in two, this one also divides land masses. Pluto's rift, in contrast to Earth's, is likely a scar from the freezing and ever-expanding ocean rather than evidence of moving continents. The age of the fissure indicates that the liquid ocean instantly began to cool after it was exposed to the air. If this is the case, marine life could flourish there. The crimson color of the water, which suggests that it is stained with organic molecules, was observed in samples that had likely poured out of the ocean on the near side. The complex organic matter with a reddish-brown color has been created in the lab by radiation akin to solar wind or cosmic rays. Therefore, it is feasible that this could happen in a world like Pluto. In addition, ammonia allows the formation of molecules necessary for life, such as the bases found in RNA and DNA. Red ammonia-laced ice on Pluto's near side is an important indicator that the dwarf planet may be rich in organic compounds. The notion, which has acquired a lot of support among planetary scientists, does not imply that life originated on Pluto, but rather that it could survive if given to the planet. The far side measurements have done more than only aid in the search for life on Pluto. They have also spawned a number of rib scientists. Scientists were surprised to see ice chunks the size of skyscrapers in the easternmost part of the near side in the initial photographs sent back from the James Webb telescope, occasionally reaching heights of 1 mile, approximately 3 times the height of the Empire State Building in New York City. These ridges are equally distributed and rise sharp and knife-like into the sky. They may reach a length of 19 miles. It would be a nightmare to try to get about in this area. Until researchers discovered what lay on the other side of the planet, however, they remained a mere blip. The current map is hazy, but it's easy to make out that the bladed topography continues around the entire periphery, reappearing on the western edge of the near side. They are one of Pluto's major mysteries, since they span a region on the far side that is 3 times as huge as their extent on the near side. On highlands and plateaus, spectral measurements show that the blades are made of methane ice, forming a belt around the equator.